Hi, this is Pavel Minařík, CTO at Kemp Technologies, and you are watching Security Field Day. In this demo session, I'm going to show the case of ransomware attack and how we detect all those stages of the ransomware attack before it really does the final impact, before it really encrypts the customer data. So these attacks, they really go through certain stages. It's not going to suddenly happen that now your data is encrypted. It has some development. There needs to be initial compromise. There needs to be some lateral movement, usually some data hoarding, exfiltration, and then we have the final step to encrypt the data. So this case is inspired by a real customer case, again, that we have seen in the real environment. And what we did, we built a lab environment where we actually simulated all those steps in the lab environment against the real infrastructure. We recorded all the network activity, and now we have, I would say, pretty comprehensive packet capture made available for education purposes that actually tracks all that activity. So we do have in our setup, we have a compromised device, which can be malware infected or under the control of the attacker. We have a Samba server that keeps and stores company data. We have a remote desktop server that will be our victim for the lateral movement, as you are going to see. And we are monitoring this environment by the Flowmon appliance. So the attacker objective is first to exfiltrate the sensitive data and then encrypt the data and ask for ransom. That's the standard scheme. So how this actually can run step by step in the environment. Whenever there is a bad actor in the environment, or when he enters the environment, he needs to do some kind of understanding what is around. So he runs some discovery to understand what other IP addresses, server services are there, so he can establish his presence and spread his activities. So that's the typical first step. Second thing that the attacker can do is some access to potentially important servers that will hold some data. So attacker can take a list of known logins and passwords, and he can run a password spraying attack against that Samba server. He might not be successful, hopefully, so he needs something more advanced. In our case, what we used and what was used in the customer case was the Bluekeep vulnerability on remote desktop protocol. So that's something you can recognize with the proper signatures for intrusion detection. On the Windows server, what was installed was a keylogger, and that keylogger actually revealed some interesting information, such as user credentials for the Samba server, where the data is stored. So now we have the valid login credentials to access the data on the Samba server. We can download them, and we can think of a method how to get this data outside of the network. So in our case, what we did, we took that data and we split the data into small chunks, and we just ping the data out of the network. It works like a charm. And this is basically getting to the final step, which means the encryption of the data on the Samba server. So responding to the threat at this stage, it's obviously too late. because the attacker is now ready to send you an email asking for ransom for giving you the decryption key for the data, or asking you for the same ransom for not putting your sensitive data on the public internet because it was exfiltrated. So usually there is an attachment to this email with a couple of documents showing that the attacker really has this data available. So I'm actually running that scenario in my lab live in the background. So now when I switch to the anomaly detection system, I will be actually able to demonstrate all these activities one by one. So we started with the network discovery. This is our attacker IP address, and we see two activities. First is ARP scan that looks for devices that are available on the same network, followed by a vertical TCP SYN scan where the attacker is looking for services that he can compromise. So again, we can see the event details, and we have the classification to corresponding tactic and techniques that are relevant in this case. Another interesting activity that was in the scenario was attack on the Windows remote desktop. So we have again the same attacker, and we have an event saying attack against Windows remote desktop. And when we go to details, we are interested in related intrusion detections. And as you can see, there was a detection triggered that says exploitation of the BlueKeep vulnerability. So after that, the attacker was able to perform the data hoarding. So he was able to download large amount of data from the Samba server. And this was followed by the data exfiltration from the network, where several different methods actually were triggered. The general data upload anomaly that will notify you about a data leaving your organization towards some public IP addresses. But what will be more interesting is this anomaly of the ICMP traffic, because as I've mentioned, attacker split the data into small chunks and ping it out of the network. And obviously, anomaly detection system doesn't like ICMP traffic with a payload. So when we go for details, we can see the event evidence. So these are ICMP packets aggregated into the flows that have been actually detected and flagged as an anomaly. And you can see it's not really a massive amount of data. It's not a lot of packets. It's not a lot of flow. So this is not a volumetric anomaly. And we have a full packet capture available. So in this case, I'm going to download that full packet trace, and I'm going to open that full packet trace using Wireshark, and I'm going to open a file called history, which is exactly the data from the buffer. So we see the ICMP traffic, we see the ping, including the content, which starts here with the file name, followed by the content that was sent out from this network. And I have first like 40 packets available for my forensic analysis in this scenario. So that was really going end to end from the detection to the analysis of full packet trace in Wireshark and showing all the different details that you can get from the system. And there are different ways how to look at those events. You can look at those events on a timeline, so you can see how these individual attacker activities actually followed one by after another, or how they were detected one by after another. In reality, this is not going to happen in 10-20 minutes, but in the lab environment, I replayed all the traffic to the network one after another.
So this is pretty impressive, and I wish a lot of my customers, because I investigate ransomware cases all the time now, would have this kind of thing, because then I could go back in time and find out what really happened. Because usually the big question also always is, did the attackers exfiltrate data? And nobody can tell. Sometimes they can show me like a firewall log where you see there's a connection, but nobody knows how much data has been transmitted and everything. So how many data points do you need for this? So how many probes do you need to deploy in the network to get a good understanding of what has really happened in the network? Because if you don't see something passing by, you cannot aggregate this into your logic. So how much collectors do you typically need for this?
Mm-hmm. Understand. You will be actually surprised. It can go down to one. Depends on the network topology and the network architecture, because all these things are actually happening between the clients, between the servers, between the clients and the perimeter. So the typical deployment is on the core switch, is in the data center switch. You don't really care about the traffic on the access layer. You don't really care about PC1 speaking to PC2 on the access switch. So all these anomalies will be actually, or most of these anomalies will be actually visible on the core level. So as an example, I can give a hospital that is our customer with like 2,000 beds, probably like 2,000, 3,000 employees. And we have detected in their environment ransomware in action that was starting to encrypt the X-ray images, and they were able to get rid of this immediately because they've seen which device in the network is infected. So they lost something like 5 X-ray images, and the problem solved. And their setup is a single probe monitoring the traffic on the core switch.
Okay, I wish I had this one in my last hospital case, because they encrypted, I think, 13 million files. And yeah, that is a big problem.
And as I mentioned, it doesn't start with the encryption. It starts with many indicators of compromise that can be detected in the network traffic. And the encryption is really the last step.
Yeah, it is. It is basically, it is the one thing where the attacker announces itself or himself to the company and saying, hey, I got you now. Everything else before has been done in secrecy. So if you can detect that, the ransom or the encryption is just the last step.
Yeah, and just an additional question to that. So that is typically the case from, let's say, targeted ransomware, where we have an adversary that is digging into the network. So besides the alarming, you mentioned you have ties into CMs, or how is normally the alarming going from your solution?
Yeah, typically depends on the customer size. Smaller customers, they usually don't have SIEM systems, so they usually go with really notifications from the Flowmon system to their IT help desk or security help desk. And for bigger customers who have SIEM, they usually use the workflow through SIEM because they consolidate other technologies this way as well. So there is a continuous feed of the events from anomaly detection system via syslog to the SIEM, where the events are correlated with firewall logs, logs from servers, and then the more like high-level incidents are being processed by the customer staff. So it really depends on the customer size, type, maturity.
Sure, makes sense. I can imagine that some customers that are maybe smaller directly looking into the console, and others that have many other sensors will just consume via syslog the alarms and then look into your console whenever there is something already flagged. Yeah.
Exactly. That's the typical workflow.
And I think also like a pre-selection in CM world, a lot is based on how much events you send, but kind of with your solution, you pre-filter all that noise and just send over the alarms that really matter. Yeah.
Yeah, exactly. The SIEM, they count events per second from anomaly detection system from Flowmon. You will get like, okay, if 1 event per second, that's too much. So it's very aggregated and directly to the point. You don't need to process raw flow data in the SIEM. You just need to focus on the results of the behavior anomaly detection from Flowmon that goes to SIEM.
Yeah, like Jasper was mentioned, a lot of the healthcare customers and so on don't have visibility into the network flows because they couldn't afford it. Yeah, so that was one of the main problems. And it's either how many flows per second or it is gigabytes per day, and both are super expensive. So it makes sense. Your model, I'm curious, how do you count? Do you just count per device, or is there also a volume in the license somehow integrated?
When we speak about Flowmon Collector, so the system that is capturing, storing, and processing the data, I think we have the most fair model on the planet. It's just what disk capacity you need for your historical data retention. That's the decision point for the proper collector, for the proper license or proper appliance. So we don't care about number of endpoints. We don't care about number of flow sources, because with some products, you get really penalized for having 20 routers. And as you are small organization with 20 branch offices and 20 routers, you can get it pretty expensive. And we don't care. It doesn't matter how many flow sources you have. It doesn't matter how many endpoints. It's just about how your network is big, how many flows per second you are processing. And if you want to have 1 month history or 5 month history, that makes the difference. So it's very fair.
Okay.
I have an additional question about if you're having more than one collector or more than one probe sending the same data, because it has the packets have traveled across the network and you're picking them up at multiple points. So you are deduplicating the incoming events, or are you generating multiple results for the same thing?
That's completely configurable. First thing is all these duplicates should be under your control. So you should know whether you are introducing duplicates or not in your setup. For the purpose of just the data collection and storage, we don't deduplicate. We store all the flows. They are always matched to the specific flow source, because you want to confirm that the traffic passed through these multiple points. And then when the data goes to the anomaly detection system, there is the deduplication feature. So you can say deduplicate because all this data are from like one logical segment from the internal network, for example. So the anomaly detection system will deduplicate flows that are measured by multiple different probes or multiple different routers prior the anomaly detection is performed. So you will not get duplicate events.
Okay, thank you.
To that, sorry for asking so much, but this, please clarify. Can you search across multiple appliances? So I'm making an example. I have 3 locations. In each location, I have one of your appliances. Can I do a search query across all of them, or I have to do 3 searches for each location, an individual search?
Now all is consolidated, so you can do just one search, and also it depends what type of appliances. You can have probes and consolidate on a single collector. So these probes will send IPFix to a single collector, and then you just have one appliance that you work with the user interface. If you have really a big environment, you may need multiple collectors. So in that case, we have a concept called distributed architecture, where you have multiple individual collectors, and there is a master unit on top of them that consolidates all the data, and it's again a single query point for all the data. So you always have a single console that you can use to query the data.
Wonderful.
Hey, I have a question about the attack. You mentioned the MITRE and the fact you use their techniques and their sub-techniques. Do you support all of the ones that are in their framework? Do you support any additional ones? And then as a follow-on question, how quickly can you go from an attack technique being defined by the industry then to support it in the product?
Mm-hmm. Okay, so one of the issues of the attack framework is that it's actually defined for all the different technology types. So it covers endpoint detection, it covers network detection response. So we obviously don't cover techniques that are related to analyzing logs from the server or analyzing processes on the endpoint. So it's only related to what you can observe from the network traffic, from the network packets. And from that, I would say if you combine the behavior analysis with the intrusion detection signatures, with the suricata on the probes, you are actually covering that network detection space of the MITRE attack framework. And how fast we are able to, there was also a question if we detect something else. Yes, we do, because originally we didn't really design it for the attack framework. We designed it based on our experience. So we have a couple of additional detection methods that cannot be really classified directly to the attack framework. Let me give you an example. There is a method that's profiling individual hosts in the network with how many another different peers they are talking. So this is not really any specific technique in the attack framework, but it's an anomaly that you can trigger that this host suddenly contacted 1,000 IPs in the network. And last question was about how fast we are at the new technique. When we did the mapping, it was actually interesting how one detection method actually covers many attacker techniques. So it's not always mapping one-to-one, it's sometimes mapping one-to-many. So I would say that when there is something new, we are respond with the software update, which is typically once per 3 months. But it's not really saying that we are not able to detect this specific activity, because on the network, you know how it goes. If the malware needs to contact multiple machines to check if that specific network service is running, you will detect it out of the box, and it doesn't matter if you have a specific signature for that specific malware, because you just do it based on the behavior of that malware. So there would be high chance that existing methods will detect it. It just not might be mapped properly to that specific attack technique. So we need to catch with that in the next version. What also makes life more difficult is the changes in the attack framework. There was version 7, now introduced version 8. So we have version 7 supported. Now we just provided update that is compatible with version 8. It may look like small changes, but actually the changes between 7 and 8 were pretty significant.
Do you have any examples of, you guys mentioned both Hafnium and the SolarWinds incident. Do you guys have any examples of how the anomaly detection system viewed those particular attacks?
For the Hafnium attack, we haven't seen the attack based on the behavior detection, because it was really single connection coming from an external site on HTTPS. Like there's really no way how you can do it. So what we have seen, once the attack was known and indicators of compromise exist, we immediately put them into our threat intelligence feeds. So we reported on communication of those malicious actors with the Exchange servers. So that was the Hafnium part. And for SolarWinds, I think it was mentioned here really as an example. I'm not able to say that I know a customer that was really affected by this SolarWinds attack, and it's a Flowmon customer. I'm aware of it, so I don't really know. It may happen, but I haven't consulted that case. The Hafnium thing was much more visible.
So in those examples, if say you've updated your threat intelligence with those signatures or there's techniques, we can then retroactively go back, assuming we have enough storage to see if we were potentially impacted. I know with SolarWinds as an example, it was just DNS requests or requests out to Amazon instances, right? So you could go back and see those destinations and those impacts.
Yes.
Excellent.
Yes, that's what you can do. Obviously, it will take some time because you will run a query against a lot of data, but you can run it in the background. It's not a problem to start it and pick up the result tomorrow, and you will go through 3 months of all the data, which may be terabytes.
Your threat intelligence information, how often do you update that? I'm assuming that they're rolling updates?
Yes, it's actually updated every hour on our end, and Flowmon appliance is running on customer premise. They call home every 6 hours by default to ask for the updates, so they receive these threat intelligence data. Maybe what I didn't mention, we have also a specific, as I call it, behavior patterns. So we developed our own technique how we can describe something like a signature on the flow level. So it's not really a signature, it's more like behavior description. And this is also opened for the customers, so they can create their own specific detection methods, as well as we are using this mechanism how to push in a new detection method that is able to detect a specific behavior in the network. So that's another thing that it's updated on the fly from the call home. It's not really a call home. It's not sending anything home. It's just getting the signatures or threat intelligence data from our update side.
Yeah, one quick one again, just in terms of the anomaly detection system. Would it the example you gave was sort of an attack on a single host or SMB in that example. What do you see, or is there a way to detect sort of lateral movement within a network? Is that one of the signatures that you would see in the anomaly detection system? And would you be able to sort of follow that in a timeline view or something like that?
Yeah, the lateral movement is one of the categories that is obviously detected as the attacker is like pivoting from one internal system to another system. So that's in the scope of detection as well. From the timeline, well, you will see it on the list of events as they go one by one, but it's not really like a timeline visualization that you can play to see like it popped to this host, popped to this host. It's not there, but there is, maybe I'm able to quickly show it as well. There is the option to do like visual analysis of the activity. So what I can do, I can say visualize event, and this is going to bring me, a specific visualization where I can actually check on what is the other activity of that specific device in the network, and I can drill down to the flow level, so I can explore the activity and other involved IPs by going really from the attacker and checking which other devices actually communicated with that specific device in the network. So this is an option in the system how you can analyze the specific activity